Today we are going to be discussing the drug called Topamax. Its brand name, of course, it's Topamax. The generic name of the drug is topiramate. The chemical name is 23:45-bis-0,1-methylethylidene beta-D-fructopyranosultamate. The drug is used for treatment of bipolar disorder, epilepsy, and preventing migraine headaches. It is recommended that you don't take this drug during pregnancy or while under the influence of alcohol. If topiramate were to react with another drug called Cymbalta, it would lower the levels of blood sodium. If it reacted with other drugs like methadone or Xanax, it would increase the side effects that the drug already has. A fun fact about topiramate is that it's also used in a weight loss medication called Qsymia, where it's mixed with phentermine. Here's what a topiramate molecule looks like. First, you would draw out a hexagon in the middle with 1 oxygen and 5 carbons, like this. All of these straight lines represent bonds between the atoms in the molecule. Now you would draw a wedge here, which also represents a bond, and another wedge here. And at the end of these two bonds are oxygen atoms. Now you would draw bonds here to indicate that there are carbon molecules on this part of the molecule. Now here on the other side, you will want to draw dashed lines. And then after you do this, you will want to connect these bonds to oxygen molecules. Then we would draw 2 more bonds over here, connecting them to carbon, and 2 more bonds branching off of this to connect it to more carbons. 2 more carbons to be exact. Then once you reach this point here, you will want to draw a dashed line connecting this to a carbon, and you would draw a straight line here connecting this to oxygen. Then you would draw a single bond here connecting this to sulfur. And then on both sides of the sulfur, you would draw double bonds. And on each side is an oxygen. And then you would draw a single bond connecting this to nitrogen. And on each side, you would draw a single bond connecting it to a hydrogen. Wait, no. Wrong letter. You would draw hydrogens on each side. This is an expanded structure of the molecule topiramate, one that clearly shows the carbons and hydrogens in the molecule. This is another expanded structure, but this time it shows the molecular geometry of each of the central atoms. So this carbon molecule right here, it's surrounded by 4 single bonds. So the molecular geometry would be tetrahedral. These two oxygens, they are both each surrounded by 2 single bonds and 2 lone pairs of electrons, making their molecular geometry bent. Each of these 5 carbons is surrounded by 4 single bonds, so their molecular geometries would each be tetrahedral. This oxygen here, it's surrounded by 2 single bonds and 2 lone pairs, making the geometry bent. These oxygens are also surrounded by 2 single bonds and 2 lone pairs, so their geometry is bent. These 2 carbons over here are also surrounded by 4 single bonds, so their geometry is tetrahedral. This oxygen molecule also surrounded by 2 single bonds and 2 lone pairs. The geometry here is bent. This sulfur atom here is surrounded by 2 single bonds and 2 double bonds, so the geometry here is tetrahedral. This nitrogen atom is surrounded by 3 single bonds and 1 lone pair of electrons, so we would call this molecular geometry trigonal planar. The molecular formula of a topiramate molecule is C12H21NO8S. And to find the molar mass, I found the molar mass of each atom itself, and I multiplied it by however many of that atom was in the molecule, and then I added all of those up. So a carbon atom weighs 12.011, and since there are 12 carbon atoms, I multiplied it by 12 and I got 144.132. Hydrogen has an atomic weight of 1.008, and I multiplied it by 21 since there are 21 hydrogens here and got 21.168. Nitrogen has an atomic weight of 14.007, and I only needed to multiply by 1 because there's only 1 nitrogen. Oxygen weighs 15.999, and since there's 8 oxygens, you multiply by 8, and you get 127.992. Sulfur weighs 32.065, and since there's only 1, you would just multiply by 1. So as soon as you add up all 5 of these values, you would get 339.364 grams. But here we're rounding to the 100th place, so that would just give us 339.36 grams right here. Here we have all the different ways that water molecules could interact with the atoms. I mean, with the topiramate molecule. So here, if a water molecule comes from outside, the hydrogen on the end of it could interact with the molecules of oxygen, oxygen here. The water molecule can act as a hydrogen bond donor because it's the hydrogen from the water bonding with the molecule oxygen. And in places like this, if a hydrogen on the molecule is reacting with an oxygen from the water molecule from outside, The water molecule is a hydrogen bond acceptor. So this water molecule right here and this water molecule right here, they're both H bond acceptors. And once again, this is a picture of all the different ways that water molecules can interact with topiramate. This is a diagram of all the polar regions on the molecule of topiramate. So here, in places like this, the carbon and the oxygen share electrons, but they're shared unevenly. In this case, the polarity would move towards the oxygen because it's more electronegative than carbon, which is the same thing you can see here, 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 and here. Now with this part of the molecule, hydrogen and nitrogen share a bond. The polarity will move towards the nitrogen because it's more electronegative than hydrogen. I also made a prediction on whether or not topiramate would be soluble in water. My prediction was it wouldn't be soluble in water because there's too many areas with London dispersion forces. Like areas like here, because the carbon and hydrogens, they interact with each other, so this area is not a polar region. And non-polar regions can't interact with water, which is the same thing that happens here, here, here. And when I researched this atom more, I found out that it is not soluble in water because topiramate is soluble in alkaline solutions that have a pH of 9 to 10. And water does not have a pH of 9 to 10. It has a lower pH than that. So if you wanted to prepare 50 milliliters of a 0.023 mole solution of this drug, topiramate, what you would have to do is find the amount of grams first. Since the molarity equals the moles times the liters, you already have the molarity and the liters, the milliliters. So first you would convert milliliters to liters. So you would divide 50 by 1,000 and you would get 0.05. So you would have 0.023 equals moles times 0.05. So you would divide by 0.05 on each side to cancel that out. And then you would get 0.46 moles. And then you would have to multiply 0.46 by 339.36 to find out how many grams are in 0.46 moles. And once you do that, you would get 156.11 grams of topiramate. So to prepare the solution, first you would take 156.11 grams of topiramate and put it into a volumetric flask. Then you would add water into the flask until it reaches 50 milliliters, then mix until the topiramate is dissolved. That's how you would make your solution. If you wanted to calculate how many milligrams of the of topiramate are contained in 2 milliliters of a 3% weight over volume solution of topiramate, first you would plug in all of these values to this equation. WV% equals the mass of the solute over the volume of the solution in milliliters times 100%. Since we already have the percent and the volume, we would need to plug that stuff in. So 3.0% equals mass of the solute divided by 2.0 milliliters times 100%. So we would multiply by 2 to solve for the mass of the solute, and then we would get 6 grams or 6,000 milligrams. So how many milligrams of topiramate are contained in 2 milliliters of this solution? 6,000 milligrams.